So for our last lesson in this module, we are going to find out how we can solve equations with variables on both sides of the equation. Our goal is to be able to say I can solve an equation that has variables on both sides by combining like terms and using inverse operations. So some vocabulary we need to know. It's the same vocabulary from our last lesson. What an equation is, math sentence showing two things are equal. The variable is a letter that stands for a number or represents a number. The solution is the value of the variable that makes the equation true. Inverse operations is operations that undoes another operation or the opposite operation. And to isolate means to get the variable all by itself. So it's going to be similar to the past videos, except for this time, we're going to end up having variables on the left side of the equation and the right side of the equation. So we want to know what happens, or what's the process when that happens. So let's take a look at some of the steps. Just like the step of the last one, we want to make sure we simplify both sides first. Can we distribute if we need to? Can we combine like terms? We always want to simplify first if possible. Okay, the second thing we do is we want to get all the variables to one side of the equation. It can either be the left side or the right side. It really does not matter. We're just going to practice by moving the variables to the left side, but you can move them to the right side if you wish to. So after we have moved the variables one side, we want to move all the constants to the other side. So a constant is just a number that doesn't have a variable, like a 1 or a 2 or a 3. It's just a number that does not have a variable on it. And then after that, we're going to isolate the variable. We're going to solve and check our solution at the end. Okay, so let's take a look at these and see what we can do. So first we have 5x plus 3 equals 2x plus 15. All right, the first thing I want to double check is, can I simplify anything? So look at the left side. We have 5x plus 3. Do we have any like terms we can combine? We do not. Do we have any distribution? We do not. Let's look at the right side. Anything we can combine? No like terms. Any distribution? There isn't. So, step 1, we've already simplified. Okay, now, step 2, we want to get the variables to one side. In this case, we're just going to get them to the left side. So we're just going to say variables to one side. So in other words, I want to get this 2x right here, and I want to get it over to that side. In order to do that, I have to do an inverse operation. This is a positive 2x, so the opposite of positive or addition would be a negative or subtraction. So I'm going to go ahead and subtract 2x from this side. And I'm going to subtract 2x from this side, but I'm going to make sure I line it up with its like term. So since 5x has an x, 2x has an x, I'm going to line those up because those are like terms. So the 2x and the minus 2x, that ends up going to 0. And then on this side, 5x minus 2x is 3x. We bring down the plus 3. We haven't done anything with that yet. And bring down on the right side my 15, because I haven't done anything with that yet either. Okay, now at this point, hopefully this looks familiar. This is a two-step equation at this point. So we're going to go ahead and just subtract 3 from both sides. And we end up with a 3x on the left side and a 12 on the right side, because 15 minus 3 is 12. And then at this point, we're going to go ahead and do the opposite of multiplication, which is division. And we end up with x equals 4. All right, let's go back up into our original equation and see if that matches. What's green? So if I plugged in a 4 right here, 5 times 4 is 20. And 20 plus 3 is 23. Okay, let's plug in a 4 over here. 2 times 4 is 8. 8 plus 15 is 23. which means we have the correct solution to our equation because 23 does equal 23. If you get one where that's not true, then we had a mistake. We did something wrong and we need to go back and fix it. So they should be the same at the end if we got the correct solution. Okay, 4x plus 2x minus 4 equals 3x plus 8. Okay, remember, first thing we want to do, see if we can simplify. So let's take a look at this left side first. Do we have any like terms? Do we have anything that we can put together? We absolutely do, because we have a 4x and a 2x. So those can be put together. 4 plus 2 is 6. So this forms a 6x. The minus 4 drops down with it. Is there anything we can simplify on the right side? Can 3x plus 8 be combined? No, they're not like terms, because 3 has an x and 8 does not. 8 is a constant. So we just bring those down because we can't do anything with those. Okay, so we have simplified. Now, after we simplify, remember, we want to take care of the variables. We want to get them all onto one side. So I'm going to take a look at this 3x, and I want to get it over here. It's a positive 3x, so I'm going to go ahead and subtract 3x. I'm going to go ahead and line it up with the 6x on the left side, because those are like terms. Okay, and let's see, let's draw a line and show what we have left. 6x minus 3x is 3x. Bring down the minus 4 because I haven't done anything with that yet. Bring down the 8. And now we have a two-step equation. So we're going to add 4 to both sides first. Negative 4 plus 4 is 0. So 3x equals 12. Go ahead and divide both sides by 3 because the opposite of multiplication is division. And we end up with an x equals 4. Okay, let's see if that's correct. Let's see, if I plug a 4 in here, 4 times 4 is 16. 2 times 4 is 8. So 16 plus 4, or plus 8 minus 4 is a 20. Okay, let's plug in a 4 right here. 3 times 4 is 12. 12 plus 8 is 20. Awesome. That means we got it correct. Our solution is indeed x equal to 4. Okay, can we simplify anything? Hopefully you're remembering that we can distribute. So on this left side, we can distribute the 2 to both of these things. Is there anything we can do to the right side? No, we can't distribute. We can't combine like terms. So let's just focus on the left side for now. So 2 times 3 is 6x. 2 times 2 is 4. Over here we have 2x plus 18. All right, let's get the variables on the same side of the equation. Now, on the right side, I have this 2x. So we're going to go ahead and get rid of it, or move it to the other side by subtracting 2x. Line it up with the other one. Let's see what our result is. We get 4x plus 4 equals, and over here we're left with the 18 because those canceled out. Now I have a two-step equation. Now I know all these examples I've been doing, these have ended up being a positive 4x, but it can be a negative 4x, it could be a negative 3x, it could be a negative. It doesn't change anything, it just means at the end we would divide by a negative number. So don't be afraid if you end up with a negative in front of that at some point. We don't have it right now, but you could. So let's minus 4 from both sides. And I get 4x equals 14. Go ahead and divide both sides by 4. Looks like we're going to end up with a fraction or decimal in this case. So 14 divided by 4 is 7/2. Or if you want to, you could go ahead and write that as a 3.5. Okay, so let's go ahead and take that 3.5. And let's come back up here and let's go ahead and plug it in to here, as well as right here. I'm just going to go ahead and throw this in my calculator. So we're going to do 2 times 3 times 3.5. Put that in parentheses will help me. Plus 2. Well, if I do that right. All right, so I'm going to go ahead and use my calculator. So we're going to go ahead and do 3 times 3.5, add 2, times all of that by 2, and I get 25 on the left side. And then we're going to go 2 times 3.5 on the right side, plus 18, and I also get 25 on the right side. Therefore, x equals 7/2, or 3.5. Whichever one you prefer. I'm okay with either. Okay, let's try this one. This one looks like it has quite a few steps. So the first thing I always try to do, that I need to do, is simplify. So I'm going to distribute first. 2 times 3x is 6x. 2 times -5 is -10. Okay, nothing happened to the negative x yet. Is there anything on this left side that I can keep doing? Hopefully, you can see I have a 6x and a minus x. So 6 minus 1x is 5x minus 10. Now the left side is simplified. Now the right side is 3x plus 3. Can anything be simplified there? It cannot. So we're just going to go ahead and bring that down. Okay, and now we have to do the variables. Move them all to one side. Now, just to show you that it doesn't matter which side it goes on, I'm going to do this a little different than the other ones. Hopefully it doesn't throw you off. All I'm going to do is I'm going to move the variable to the right side this time. It's the same thing. So we're going to take this 5x and we're going to subtract it over to this side. Why? I just want to show you that it can be done both ways. So this would cancel out, and I'd be left with -10 equals 3x minus 5x is -2x plus 3. And now we have a two-step equation. Okay, let's change colors. We're going to -3 to both sides. And we get -13 equals -2x. Then at that point, we're going to go ahead and divide both sides by -2. Sorry, I'm running out of room. So I end up with x, and -13 divided by -2 is 6.5. Okay, let's go ahead and throw that in. So I'm going to put a 6.5 in right here, and a 6.5 in right here, and a 6.5 in right here. So first I'm going to do 3 times 6.5 minus 5. We're going to times that by 2, and I get 29 on the left side. Oh, I forgot to minus the 6.5. Silly. See, we make mistakes. So we're going to do minus 6.5, and I actually get 22.5. Okay, let's do it on that other side. 3 times 6.5, add 3, and I got 22.5. See, that's why we check our work. To make sure you have it correctly, I do. Therefore, x equals 6/5, or if you want to write it as 13/2, it's the same, it's equivalent mathematically. So whichever way you like to see that, I'm okay with whichever way you want to do it. and the computer should answer it as well, or it should accept it as well. So if you have any questions, make sure you reach out and let me know. So hopefully we can say I can solve an equation that has variables on both sides by combining like terms and using an inverse operation. If you can't yet, after the assignment, you should be able to.